Hello, welcome to Bedroom Builds at the rsytup series, episode 6, uploading a video, coming from the previous episode where we implemented the YouTube API. In the main code, we made our thumbnails, so that was happening up here. And once we have them, we can now successfully upload a video and in succession to that, upload the thumbnail on top of it. And that's exactly what we are doing in those lines. So we create our video service. The CL stands for client. And then we would use the upload file function that was newly implemented with our client and the options from our command line parser. After that, we print the video ID out to the user. And this one is actually very important because we need that in the next step. If the thumbnail option is a valid value and not none, we actually create the thumbnail service. We call our upload thumbnail function again with the client, the video ID, and our thumbnail file name. And once this is done, we have one more feature. There are playlists. So in my case, I would have one playlist for the From Python to Rust series and another one for this one, the rsytup one. And here, this would get added to this playlist as well. Once we have the video ID, we can use the add to playlist function to do that. This concludes the normal upload part, but I've also added an update part to the main function. So let's a quick look at that. So down here in this update thing, we didn't have a lot of code, but now it's fairly packed with stuff. This is tailor-made to one operation that I needed to run once. The basic idea was to update the description of every single video and add a URL that points to my Git repository. First, we would create a list of video informations that we want to work on. So that's why we create this vids, either from a video ID that was handed over. So only one video whose ID we've looked up on the YouTube user interface, or we use this magic uploaded video ID to fetch all videos uploaded to this channel. In this next block, that's also a custom thing. I wanted to regenerate the thumbnails for all of my videos. What I would do first is collect out of the path for the thumbnails all the files that are found in this directory. And this will be used later down the line. Here I'm doing some debug printing to know if it's correctly done or not. Here I'm producing a file extension that has to be done this way because the file names are of type OS string. And in order to not clutter my code too much, I instantiate that as a variable up here. Then I create the thumbnail service. And now I loop over all the videos that come from up here. And what's happening is I'm getting the episode number and the title out of them by splitting the text at the dot. So if you look at the titles of my videos, they would have a number, dot, and then the text title. And the other thing that's common with all my titles is at the end I would have a dash that says From Python to Rust. So that's not part of the title. That has to go away. So what this algorithm does is it splits at the first dash found in the text. So the dash before the From Python to Rust. And when that happened, we can now do pattern matching on the tuple returned. And this will be sum. And we only care about the first one. This is why I use the underscore for the second tuple value. And what I do now is I use this text that I found as the first half before the dash and trim the white space out of it. And this will become the episode title. If this split once does not find a match, so none, I will actually directly use the text. This way, this is fallback safe if one text does not contain my From Python to Rust suffix. Okay, we made it to this line now. Here I'm using the entries that we've collected up top, where we were looking for all the files in the directory where I store my videos. And what this is doing, it basically is looking for a video that has this episode number to now have the correct video file name to produce a new thumbnail. So we are iterating over all of those file name entries, and now we filter them. So the VFN is the video file name. Once we have the file name, we can now use a map. This is a map on top of an option, not a map on top of an iterator. And here we can figure out if we can with a toString and starts with episode number. The episode number we figured out up here in this sum match. And if that's the case, and the extension of the file is the mof extension, so now you understand why I didn't want to have this long expression down here, then this becomes filtered out. We take the first result we find and collect it into a path buffer. Now we have the video file name that we work against. Here is debug output to verify that. And from there, we keep going. We now create the thumbnail path name. So this will be a JPEG. And we create a new screenshot using our FFmpeg library that we built. Once we have the screenshot, we can now make the thumbnail. And once we have the thumbnail, we can call our upload thumbnail code. If I'm about to change the description, however, we go to the next if block. So if we now hop down to 27, we can check if the description is supposed to change for the video. And if that's the case, we can read the file name that was passed. So this way it's much easier to do some formatting like new lines and stuff like that. If I was to pass that as on the command line, that would be fairly annoying to do. Once we have read the text file into a string, we can now use the change description function to change the description. And the last one that's not implemented yet, if we wanted to add the video to a playlist or videos to a playlist, that's not yet implemented, but it can be done because the function to add a video to a playlist exists already. If you're wondering what's up with all these new things that are popping up here, I am playing around with NeoVim and the LSP Rust analyzer, and this is giving helpful information of types returned, parameter names, as you can see here, and it also gives additional information as in diagnostics of what's happening in the code. All right, let's hop over to the actual code of uploading a thumbnail or a video first. This means we have to jump to our YouTube source. And the first thing that we have seen when I was going through the code was I had all these video service, a thumbnail service, and even worse, continues. We now have also a playlist service and a channel service. The only thing that changes in them is actually these service structs that have to be constructed. So those service functions should become a single macro. Then I don't have this code repetition. But for now, it was done by copy paste because that was the fastest thing to do. So here we can see the video list function, that one we already used when we implemented the YouTube API. And we're going to hop down to the upload video function. So I've scrolled down to the upload file function to show it in its full glory. What this one is doing, it gets our video service, the client, and it gets handed the upload options. And with that, we start with the YouTube API stuff. So here we want to get all the fields back. And then we have to create a video snippet where we actually hand over the title, description, the tags. So the tags like the hashtag thingies that you know from other social media. Then there are category IDs that you can look up on the YouTube API that we also can customize on our command line. Then the English language is a default language that's hard-coded as of today. And the same is true for audio. This can, of course, become an option at some point. The status we want to also provide. Otherwise, I would have to click around in the user interface, and that's exactly the reason why I built this thing. So there will be a predefined privacy status that I like. The publish at date is computed. If you look at episode number 1, you can see how we compute the publish date. Then this is not specifically made for kids. It's probably suitable for kids what I'm doing, but it's not specifically made for them. So I'm declaring that false. And then once we have defined those two, we can now wrap them up into a YouTube video struct, handing off the snippet and the status. And with all of this, we can now create the parameters needed to make the JSON request that will be handed over to our insert resumable upload method of the YouTube API client. So these are the parameters and the video. This is in theory resumable. I have never tested what happens if the internet connection goes down during an upload. It should be able to retry, but this is not implemented as of now, I think. So that's a to-do for the future, for sure. The way that this works is we create this resumable upload that takes a video file. So we can now open the file that was handed over, and then we can call the resumable with upload file and the file handle that makes it upload the video. After we've done that, we are printing the video ID returned. So the response ID will be that, and we get a full debug output of the full response from YouTube. This way we can maybe figure out some other info that we want to look into after an upload. The return of our function is a string, the ID of the video. That's what's happening in this OK line. And up here in the return definition, you can see it's a string. Right, we have uploaded a video. Uploading a thumbnail is next. So that's the next function. This is simpler because a thumbnail doesn't have all the metadata like a title and description and whatnot. So all we do is we set the parameters, which is the video ID. We again do a resumable upload, and this time we pass in the thumbnail, and then we upload the file. We get the response as a debug output, and we return the unit type to show that everything was fine. We would error out, as you can see here, we use the question mark operator to return an error if something broke during either constructing this resumable upload or the actual upload. Now add to playlist, that's a more complicated one again. So here we now have to construct the parameters for the playlist. So we have to know the playlist ID, of course, and the resource ID of our YouTube video. This is very simple. It's actually just a video ID, and we have to hard code the kind that we want to add to our playlist. Once this is done, we can use the client's insert method to take our parameters and actually add the item that we have created. Right, changing description. That's a bit more of a mess in the documentation. You can see that it says we have to actually fully update all the info because we cannot just update one field apparently. So if I want to change the description, I actually have to make sure that all the other flags that we've set before, like for example, is this made for kids, or the tags and stuff like that, have to exist as well. So what this function does is it actually uses the videos list to figure out the information of the video. So this is now limited to the one video ID that we are looking into. It will still return a list because the same function could give you many items. What we do is we take the first one, once we have this one, we can now figure out the snippet information. So we copy the information that YouTube gave us. Now we figure out the old description, and that is the reason we do that. Right here we can decide what happens to the description that was passed into our update function. We can either append to the existing text, we can replace to the text that came in, or we prepend to the text of the description. That's the most minimal templating engine, if you want, that exists to mankind, but it's still a valid thing to do. And I used the append one in my case, but if you were to fully replace your description text, that works as well. Or if you want to tell people something in the very first line of your description text, you can use the prepend enum variant. So once we've computed the new description, this is using the cool feature of Rust where we let a variable become the result of one of the match branches. We can now construct again the parameters as we always do for the YouTube API, then the video information, and we run the update command. Next is the uploaded video list. So that's more of a mess, because in order to know what's going to happen or to maybe preview what we will do, it makes sense to get more information than just the ID of the video. So we get the uploaded video list, but this returns a vector of YT with structs, and you can see the definition down here. It has the ID, the title, and the description of the video. That makes it easier to be sure we have the correct videos to work with. So what's happening in here is we have to, and that's why here's the pseudocode. If you were to write this in, I don't know, JavaScript, we have to get the first items, content details, related playlists, uploads. So these are all uploaded videos on your YouTube channel. In order to get that, we are accessing first the items, and out of those items that I now called channels, because this will be the channels on your YouTube channel, you can take the first one. Then we have the channel that we actually want to look into, and here we get the content details. So now we are here in this pseudocode. We can unwrap because this will work. The first one always exists. And then we get the related playlists. Again, we can unwrap because this first one is guaranteed to exist. And we get the uploads. Once we have that, we actually have the ID of this channel. This one is now important to, again, connect to the playlist service and figure out the playlist. And then we can list the playlist of this channel ID. So let's look into the list playlist function. This should actually work with the fancy go to definition, and it does. So here we have the list playlist thing. What this now does is it creates again an API query parameter that fetches the thing, that fetches the video information. We get 10 videos per loop, but here we create our infinite loop to do. But here we create an infinite loop to fetch 10 infos until we have fetched all infos possible. The maximum you can actually fetch would be 50. So there is a limitation anyways. You have to implement the loop correctly. That's what I've done here. So first we list, then we again have those items that we want to look into, and here we can now loop over the videos, get the informations that we want to put into our YTvid struct. And here we can also, because some of those videos might not have a title, for example, or might not have a description, create an not available string for them as a cop out to not fail or to have to use the option. And once we have done that, we can now return a tuple of the video ID, the title, and the description. So This triplet of information, as you can see here by the Rust analyzer, is an option of this tuple with 3 elements. Gets destructured into a video ID, title, and a description. And these we use down here to construct the ytvid struct with a copy of the video ID, the title, and the description. So now the vector of all videos holds the first ytvid. Once this is done, we can continue looping. However, this is only happening if the next page token is part of the response. So if there is a token, then yes, we have a token and this will be used to fetch the next information. If this token was not found, so a non-response, we break the loop. So this concludes the functions necessary to upload videos and to manage or modify the existing ones on a YouTube channel. This is so far tailor-made for me, but now that it's open source and online, we can continue to work on that thing and make it useful for other people too. And I've thought it's a good introduction into how Rust works using a practical application that actually does something useful and not some abstract default algorithm example code. This series is more or less concluded. I might do some new episodes when there's a new amazing feature added. Thanks for watching. Coming up next on Bedroom Builds is to be decided.